Hello everyone. In this video series we are going to see about the construction and working of light emitting diodes. In the previous video we have discussed about what is an LED and its working and its acronym, why it is being called as light emitting diode, and we have also seen the evolution of light emitting diode starting from the basic from since 1901 till now. What are the advancements in LED and who actually coined this, we have seen in the evolution part. So in this video we are going to discuss about firstly the construction. So an LED, this is how an LED structure looks. So an LED consists of a chip of semiconductor material doped with impurities to create a PN junction diode. The chips are mounted in a reflecting tray in order to increase the light output. The contacts are made on cathode by means of conductive adhesive and on the anode side via gold wire to the lead frame. The plastic case encloses the chip area of the frame will give illuminance to the light which is being emitted from the diode. So this is the construction of an LED. So we have seen you have two lead frames and you have a positive terminal anode and the negative terminal cathode, and we have the semiconductor material which is being given as the yellow color frame, and around the semiconductor material we have given a coating of the reflective cavity which is in the shape of a semicircle so as to illuminate the light which is being radiated by the semiconductor material. And also we have a wire bond so as to give supply to the semiconductor device. And also we have a epoxy lens case wherein which these all the materials which we have discussed above will be enclosed. The N-type semiconductor, we have P-type and N-type material together forms the PN junction diode, which is the same for LED also. So here the N-type material is a type of semiconductor obtained from a pentavalent material like arsenic, which is added to pure silicon crystal. So each arsenic atom forms covalent bond with the surrounding 4 germanium atoms with the help of 4 of its 5 electrons, and remaining 1 electron, which is the 5th electron, is superfluous and is loosely bound to the arsenic atom, which is like the extra atom. That is the one which contributes the current flow. And the P-type material used for the LED are obtained from trivalent material like boron, which is added to a pure silicon crystal. So boron has 3 valence electrons which forms covalent bond with 4 surrounding silicon atoms, but one bond is left incomplete and gives rise to a hole. So that incomplete hole is because of the deficiency of electrons. So hence boron is an acceptor impurity, which is called as an acceptor impurity, causes many positive holes in silicon crystals as there are more boron atoms, thereby producing a p-type material. Next we'll see the working. So the working is very similar to an ordinary PN junction diode. When a negative end of a circuit is connected to the N-type layer and the positive end is connected to the P-type layer, then the electron and holes starts to move. If you try to run current the other way, which is nothing but connecting the positive to the N-type material and negative to the P-type material, then the current will not flow. That we know just as in the PN junction diode. Since no current flows across the junction, it is due to the holes and electrons are moving in the wrong directions, as you see in the circuit diagram in the picture given here. So we see that p type is being connected to the holes, and positive is connected to the positive terminal of the battery is connected to the p-type material, and the negative terminal of the battery is connected to the n-type material. So this, since light poles ripple, this positive and p-type material will opposes the holes, and also it makes the holes to move towards the junction. The same happens with the n-type material and the negative terminal also. Hence there will be a movement of holes and electrons towards the junction, and hence at a point the junction breaks and the electrons will move from the negative terminal to the positive terminal, which constitute a current flow, which is very similar to a normal PN junction diode. But let's see how this LED works. When the current flows across the diode, the negative electrons move away and positive holes move the other way. The holes exist at the lower energy level than the free electrons. So the free electrons will be at the higher energy level and the holes will be at the lower energy level. So therefore, when a free electron falls, it loses energy. This energy is emitted in a form of photon, which are nothing but bundles of energies, which causes light. And that color of the light is determined by the fall of electron and hence the energy level of the photon. So whenever an electron is being accepted or it is loosed from an atom, in either way